Okay, two variables are directly proportional if the rate of change of one with respect to the other is constant. So this just means you're going to get a straight line. So the example we're going to use is water poured into an empty tank at a constant rate. If you were traveling from one distance to another and you put on what's called cruise control, that keeps you at a constant rate of speed, or at least it used to be before cars got really smart. And then you can tell exactly if you traveled this distance over what time, that rate of speed would be constant. So it gives you a straight line. We're going to use the rule y equals mx, and there is no plus, because the plus c would be where we would cross the y's. But we're actually starting at the origin, or from 0. The gradient, so that takes that out. The gradient, m, of the graph is equal to the rate of change, y, with respect to x. I'll show you what I'm talking about. It's pretty simple. Water is poured into an empty tank, and this is important, at a constant rate. So if you had, similarly, you think if you have a hose, if you're ever doing any gardening, sometimes you have a little clip there, and the water will come out, you can clip it, it stays at exactly a constant rate, and then you know. Maybe in this case, it took 3 hours to fill a tank that has 6,000 liters, so we know that. So question 1, what is the rate at which water is poured into the tank? So we know that the rate is 6,000 liters in or over 3 hours. So we want the rate per 1 hour. So how many liters is that in 1 hour? Divide that by 3, and we'll do that with this side as well. That tells us 2,000 liters is 1 hour. So that's 2,000 liters per hour. Then we're going to draw a graph of V, volume. We'll put volume on this side in liters, and then on the bottom we'll put time. And what's time in hours? Could be, there's different units. So this is the beginning. We have 0 hours. Let's go over here, give ourselves a little room. 1, 2, 3 hours is as far as we go. And the volume, I might give myself some space. So this is 2,000, 4,000, 6,000. Again, this is volume in liters. I know that I'm going to start from 0 hour, where I've got no water, and then after 3 hours, I have 6,000 liters in that tank. So there's nothing stopping me, because I know that this is a constant rate. I've drawn a line right through there, and there is our linear relationship I've drawn my graph. Now we're going to find the gradient. So to find the gradient, we're looking for the rise over the run, and in this case, the rise is 6,000. Big gradient over the run, and that happened over 3 hours, and that gives us a gradient of 2,000. So that's our gradient. So now we can have a good time, and we can find the rule for V. So the rule is, we know because it's constant that y is going to be equal to m times x. And in this case, we're going to go ahead and replace our y with V, because on the y-axis here, that's actually volume. And we're going to replace m with 2,000, and the x-axis is actually t for time. So now we've got a rule that says, this is a pretty simple example. You could probably work out without the rule, but the rule is going to be helpful when we have more complex examples. So now we have D. Use your rule to find the volume after 1.5 hours. So you might be able to just go along our graph and find it here. We're guessing, I think it's going to be 3,000 from just looking at it. But we're told to use the rule, so let's use the rule. The rule is volume equals 2,000 times time. And so that's 2,000 times 1.5 hours, or 1.5 of 2,000. And 1.5 times 2,000 is indeed 3,000. So the volume after 1.5 hours would be 3,000 liters. In part 2 of that, we're going to find the time that it would take to fill 5,000 liters. So 5,000 liters, can we have a look if I drew my line right? Maybe 2.5 hours? Let's see. So volume equals our gradient times t, and we're looking for the time. This time we have 5,000. And if I divide both sides by 2,000, so I could write it out. And that leaves us over here with the time. 5,000 divide 2,000 is 2.5. Therefore, it would take 2.5 hours. Just squeeze that in there. And sure enough, that fits with what we expect to see and have seen on the graph.